like to introduce the folks from Albert Invent. We have two speakers, Bob Olson and Jonathan Welch. Bob is the VP of Growth and Strategic Partnerships at Albert, and he brings over 20 years of experience in chemicals and life sciences to AI. Bob is an experienced CMO, and prior to Albert, he held sales and marketing executive roles at DuPont and Deloitte. He was a longtime ISBM member. Bob is deeply involved with industry leaders to digitally transform their R&D operations and accelerate innovation. Jonathan Welch is head of data science at Albert Invent. He has a PhD in applied physics from Harvard and deep background in learning and quantum computing. He was recognized as a 30 under 30 by Scientific American and brings over a decade of experience in research, engineering, automation, and data science. He's held senior positions leading teams developing ML solutions in voice and vision biometrics, speech recognition, NLP, chemistry, and material science. He's passionate about leveraging large real-world data sets and developing the tools and educational paradigm necessary to empower scientists and engineers to use that data and drive innovation. So these guys are going to tell us a little bit about what they do, and then after the presentation after them, they're also going to demonstrate it for you. Please bring your own questions then. That'll be great. Here you go, guys. Jan, do I have your, thank you. You still want to keep talking, I know. That's your, it's okay.
All right, good afternoon, everyone. Thank you for the introduction. One of the nice things about going a little bit later in the day is you get to steal best practices from everyone else. So I didn't have a polling question in mind when I got here, but I'm thinking of one right now. So how many people are directly involved with the new product development process in their companies? All right, follow-up question.
How many people would you announce that to the group?
I would say 80%, 70–80% of the room. Of those people, how many are interested in accelerating the new product development process? I think about the same number of hands.
Great.
Great. I'm going to introduce you a little bit to Albert, and Jonathan is really going to carry the day and do a deep dive into AI for innovation. Lynn covered the background a little bit. I'm used to sitting in this audience, right? As a longtime member of the ISBM, I've sat in this group for many years, either through DuPont or FXI, but today I'm spending more of my time with CTOs rather than CMOs. So Jonathan and I, Jonathan leads our data science team. We'll take you through a little bit more of a deep dive. Just by way of introducing Albert, our mission at Albert is to accelerate product development, accelerate innovation, and help science-based companies with their digital transformation. We're a cloud-based R&D platform supporting data management and all the activities across the laboratory environment, laboratory operations, all with a focus to help our customers increase speed to market, improve productivity of their lab operations, and also reduce risk. We do this because Albert was designed from the bottom up to break down the barriers that exist between silos and disparate systems in the R&D process. So we're an end-to-end data platform supporting R&D, not just one source, as we like to say, one source of truth for data, but also providing the tools that scientists in chemical companies, material science companies need for their day-to-day work. And that's everything from helping them understand what inventory, what materials are available in the company, through to regulatory information, and some powerful tools to help them with formulation and experiments, and even sampling. So many of our companies develop MSDS sheets. I know back in my previous life that could take days or weeks, and now it can be done at a keystroke. So all of this, though, is dependent on having clean, structured, common platform for data. And one of the things we're doing to help our customers is overcome the challenge of AI's aspiration, the power of AI, with the struggle to have the foundational data to actually harness that AI. And that's what we're going to share today. So the previous slide we just saw was sort of a laboratory operations view of our work. This is much more of a product development view, and that's where we're going to hang a couple of case studies on this. It's sort of a typical stage gate. I had the pleasure of talking to Bob Cooper yesterday, and I won't put dates on it, but it was years ago in a conference just like this, decades ago, where young Bob Olson and young Bob Cooper, he introduced me to StageGate, and I've been using it ever since. So your work is still alive and good, Bob, so thank you. So with that, I'll turn it over to Jonathan to walk you through some examples.
Thank you. So yeah, my name is Jonathan Welch. Thank you for giving me your time today. So we're not going to do like an overview, a detailed overview of StageGate, but it provides a nice framework for kind of understanding. There are a lot of different ways the product R&D workflow to figure out what different types of AI can be used in different stages. And so we're going to give you kind of 3 use cases today about how we help to get a product like our platform like Albert, which is about digitalization and about digital transformation in the chemical industry, how we've helped our customers use AI not only to get this kind of product into their environments, but also how once they start to collect that clean structured data, what types of things they can start to do to drive innovation and capacity. So we'll start with the first one, which is getting insights and scoping. So a big challenge for us as an organization is figuring out how do you take a massive chemical organization that has lots, decades or even a century sometimes, practices and protocols that are in place, and actually help them undergo a real digital transformation. We have one customer that we're talking about. They have done a big internal survey, a couple of them, to try and help them understand, where was their company, what were their subject matter experts, all the way through their upper management, how were they feeling towards digitalization, digital transformation. And they did this in a response form that was 20 questions, completely free response. And so they wanted to help actually analyze it. So they had a team of analysts they were doing internally, but we also said, look, we've been working with large language models and generative AI is kind of the theme today. So let us take a crack at it and actually see what kind of results we can get. And so we treated this as sort of a VOC style study, where we took all of the answers that we got from a variety of different stakeholders in the process. We submitted them into a large language model after doing a little bit of pre-processing to tag it with certain types of metadata to be able to give it things like, this type of response came from a C-level executive versus a VP versus a subject matter expert versus a technician, so on. By doing that, you actually open up a tremendous amount of ability, as you kind of learned during Chris's talk this morning, that you have to give it the right context. You have to give it a lot of insight into what the actual answers that you're presenting and the data you're presenting, what does it mean, how should it understand it, because when you do that, you get some really interesting results out of it, right? I'm not going to go through all the details here. This is purely just output that came from the large language model, right? And you can see in here that there's details about how each of the individual stakeholders are responding to ideas about the technology platforms that were internal to this company, the types of things that they were concerned about, the things they were excited about, what types of technologies they thought they'd bring in to actually improve their workflow. And this is really nice to actually work with a customer in this way, because now as you're working with this large language model, you're using data that came from inside your organization, and you can actually have a dialogue with the language model, as it were, to actually ask them, well, what are the things that they need to change to improve, to actually undergo a digital transformation, and bring in a platform that enables them to be fully digital in R&D. And when we do this, it's nice because now you're using their data, but you can actually look at it and say, well, those are the types of problems that we actually solve. And so from our perspective, it helps us understand how do we make a better product to fit our customers' needs. But on the other hand, we also grant then our customers a tool that they can actually interact with and ask questions about their internal organization to get those deeper insights and get them very, very quickly. One of the things we also like to do when we do these kinds of exercises is just kind of have fun and say, okay, give us a 90-day action plan. This is completely generated by a language model. Some of the things up here are probably very obvious, right? There's best practices and common sense, but a lot of times, because it's based upon the data that came from the internal of the organization, you actually can get a lot of interesting insights about how you can actually improve your processes, use actionable insights to be able to do that. So this was kind of trying to be a part of the generative theme today kind of thing, where this is a way that we can kind of help customers figure out internally how do they help their organization undergo digital transformation. But once they do, that's where it kind of comes in the side of things where Bob was indicating you want to have this clean, structured data in your R&D process. So a lot of times when we go into chemical companies, they're still working in paper notebooks, they're still working in isolated Excel sheets, and it's very hard to be able to build machine learning that's actionable based upon that type of infrastructure. And so what we do is we help them come in, we help them actually fully digitize their lab, like Bob said, everything from inventory management to electronic lab notebooks, or the equivalent of the LIMS, or everything that kind of that full end-to-end process. Because once you have that, then you can begin to actually do really interesting innovation practices towards developing new products. So as an example, in the chemical industry, a lot of the types of products that we see our customers making fall under the category of management of change, right? This is where you take a product you have today, customer comes with you some new requirements, you say this product's not quite there, but what are the fewest number of steps I can take to get from where I am today to where I need to be? And so one of the ways you can actually start this process, obviously, is to ask the question, what have we done before? What is our organization actually capable of? And you can have all your data in a big structured database, but once it's all in there, it can be very hard to query sometimes. But now here's another way that generative AI can actually help, right? So here we have an example of generative AI that is not actually consuming any of the raw data. It's purely acting as an interface layer. So Chris mentioned earlier in his talk that large language models can do translation between different languages. Well, one of those output languages can be things like programming languages. They can be things like search syntax or SQL queries, things like this. So once all of your R&D data is actually in a clean structured form, you can actually now build natural language interfaces that actually sit on top of that. And with the instant query, you can have anybody in your organization understand, where should I go to look to start this management chain project? Where can I go to find the most viscous material that we've ever manufactured, or something like this, right? So this is one way that we've seen success in being able to help AI kind of lead in the right direction towards innovation. But another way we see it is in sort of more traditional predictive analytics side of things. So once all of your data is in a single structured sort of ground source of truth, then you can build more traditional machine learning models, more traditional types of AI on top of those that predict things like different material properties. And what's really interesting is that anybody who's ever done any kind of optimization problem is familiar with the fact that you can't simultaneously optimize multiple things without losing out in one or two of those different degrees of freedom, right? Everything comes at a cost. One of the things you can do, though, with AI, once you've got all of your R&D data in a single place, is you can build predictive models that actually help you to figure out how do you simultaneously optimize all these different degrees of freedom. And you can interactively explore and work with it. The whole idea here being that traditionally, if you were in a lab, you would have to go for each one of these points, you have to go run an individual experiment. But a lot of times what we see in R&D organizations is that these types of experiments have already been run thousands of times, right? And oftentimes they're repeated. Once everything's in a centralized location and you start to build predictive models on it, now you can sort of do sort of virtual product development. You can actually see what might happen, and you can narrow down those possibilities to things that are actually worth pursuing and actually worth trying, and then you can save a bunch of time and money to people and laboratory costs. So the last thing I'll talk about in the last few minutes is now we've got an idea, we've got a strategy, we've figured out where we're going to go, the experiments we're going to run, we start to collect a bunch of that data. Once we've got all that data in a single place, now we want to be able to actually quickly converge on the product that we're actually trying to develop. So this came from a use case from a customer that had a regulatory constraint where they had to phase out a particular formula component because of new regulations that were coming in. And they have been trying for about 18 months to try and cover this design space and find a series of replacement products. And they were not converging on what they needed, either in terms of cost or in terms of the complexity or other regulatory requirements. So they brought all that historical data, we loaded it into our platform, and we submitted it to what's called a Bayesian optimizer, which, if this isn't familiar to any of you, it's basically a system you can imagine where you've got a machine learning model that takes some formula information and it makes property predictions. And the optimizer will then try a variety of different inputs until it finds one or a series of candidates that actually converge on whatever the properties that you're actually looking for are. And it does this in an intelligent way that is not just completely random. When we did this, what we ended up getting was a series of candidate formulas, some of which were totally outside of the design space, the types of experiments they had tried before. They were within the design space, but the chemists had never tried them before because they were following traditional design of experiment style operations where you grid things out according to what the types of variables and knobs and you adjust are. But once they had sort of a good initial starting point, once you submit to an optimizer at that stage, now the optimizer, the AI, can actually search around that design space for candidates that you may not have been able to try because of traditional DOE, which are restricted. But in the end, the AI will give you candidates, it will give you confidence intervals about, is this going to work? Do we think it's actually going to work or not? And based upon that, you can find new novel things to try. So I think I made it in time. So the bottom line on this is, in the product development, anytime that you bring in a new tool like this, it's really important to understand you have to have a very structured foundation if you want to succeed with AI, right? You can do project level things, you can do, small projects, but if you want to do organizational level initiatives around AI, you have to have some way of having that structure. And if you've got this data infrastructure in place, then you can actually begin to apply some of these techniques, which will lead to far fewer iterations to developing products. Your personnel will most likely be more productive because now they've got sort of a digital assistant that can help them. Things get faster to market. It's a competitive differentiator. And I do suspect, although I can't back this up yet with data, but I do suspect that as time goes on, having these types of AI tools available to your product and R&D teams is going to be a big part of what keeps people there. Because if, competitors got, AI that helps make products faster, and it's demeaning to not demeaning, demoralizing to not have that kind of tool inside of your toolkit. So I do think this is going to be important as the future goes. So I think that's it. Oh, I've got one more thing, which is a kind of summary. I kind of summarized the last one. So thank you for your time. I'm sorry I went really fast, but we had a short period of time. Are there any questions?
I've got one. Yeah, you spoke to like the departure from like the typical DOE kind of like high-low
Yeah.
2 point. Was the artificial intelligence able to find like, were you exclusively interpolating
Yeah.
between 2 data points, or were you
It's a good question.
extrapolating?
Yeah, no, that's a good question. This is a very important part about machine learning in general. As a rule, machine learning is not designed to do the broad extrapolations, right? It needs to understand the design space well. So when we showed the slide of having sort of find areas, those broad strokes that were set up by the DOE, those set good boundaries to be able to do minor interpolations and explore things. This is not a process that is guaranteed to converge instantly, right? The real process typically goes, you start with design, you get some candidates, you try them, you go back, you feed it that data, and you will slowly converge in this active learning cycle.
Got it. And I'm inferring that was always a linear conversion, so there's no non-linearity assumption.
It really depends on the problem, right? So you mean in terms of the models themselves?
Yeah.
Yeah, so these models actually, these can be linear models, but they can also be like neural nets, they can also be random forest. I mean, there's a lot of non-parametric models that can come into this as well. So if you're talking about a linear model, then extrapolation is totally possible, right? Because the trend obviously is going to continue in a linear fashion. In most of the cases, when we're talking about formulations of 10, 15, 20 components in them, it's not a linear relationship. And so it sometimes needs something more complicated.
Does the capability give you, can you access sort of public material databases to complement your own internal material database, so you're not excluding materials that maybe you've never worked with,
Yeah.
but they're out there?
It's a good question. Yeah, so it's a hard question to answer directly because the short answer is that it can be connected to anything like that. But in terms of how usable that public data is also, it's a quality problem, and it's also a measure of what goes into the model, right? If the model is also doing featurization in terms of chemical structure, absolutely. Then you can go out and you can look for ways in which this chemical structure is similar to what I use, and it may be able to interpolate enough to push you in the right direction. But if it's purely just numerical data saying I'm using from A, B, C to D, then it may not be that useful. But certainly, yeah, you're thinking in the right direction.
Just have a question. So as a raw material supplier into a finished goods industry, you use a tool like this to create an interface or tools for your customers to select between your products or just like the applications of your products. So if I was going to innovate a variety of choices in a coating with my raw materials,
Right.
there would be ways that I could use this to do that, either internally or push it out to them.
I think the answer is yes, but let's talk offline and I get more details before I answer it in full, because I think I'm out of time.
Yeah,
But
I think that's
yes,
a great one
let's
to
talk
bring to that,
after.
for that. I have one more, Jonathan, that came in from online, and they said, how do you handle the delicate issue of IP protection?
Yeah, it's a very good question. So in a system like this, all IP boundaries, every single tenant, when you use a platform like this, is totally isolated. And so if this is the question, the answer of how do you make sure that all of your IP is maintained and protected, that's a huge piece of security infrastructure that's in place to actually do that. I don't know if that's answering the question or not. Okay.
Right, so give us 20 more minutes and you guys will be down in this corner, right?